Okay, we're going to take a look at trying to sketch this cubic using derivatives to help. Okay, so this is a curve sketching example. All right, so we're trying to graph the cubic and we're going to use its derivatives to help us come up with characteristics of the graph. Okay, so let's start by looking at a sign diagram for y equals. So y equals is the cubic, which I have factored here to help make things a little easier. Okay, so there's three critical x values that we're looking for to put on our sign diagram. One, we want where y is equal to 0. So I'm going to use the factored form here. And then we get x equals -1 and x equals 2. And x equals 2 is there a repeated number of times, which means there's a bounce there, so the sign won't change. And that can help us with our sign diagram. So these go in as straight lines on the sign diagram, so -1 and 2. And the straight line just shows us that's a 0 of the sign diagram. And then the second thing I look for, is there anywhere that y does not exist? And there isn't, because there's no x values that divide by 0. So there's none. If there were some, these would go in as dotted lines, and these go in as straight lines. And then the third thing I look for is there any endpoints? And there's none. Because there's no restricted domain, and a cubic has an end behavior that goes on to infinity. All right, so now we're ready to find the signs for the y values. So you can just test values. Like an easy value is 0, which is in between the -1 and 2, and that gives us 4, so that's a plus. And then you can use what you know about even or odd number of factors being there to switch your signs. So because the -1, the factor's there once, that's an odd number of times, so it will cross the axes, and so it'll be a negative on this side. And then because this is there, the 2 is there an even number of times, the sign will stay the same, so it's a plus. Or you could just test values, like put 3 into y equals and see that you get a positive value. Okay, so let's just interpret what this means. So this is a sign diagram for y. So that this is when y is plus or minus, which means this is below the axes, above the x-axis, above the x-axis, on the x-axis, and on. So that's what that sign diagram tells us. It also tells us the zeros. So we have -1, 0. And 2, 0. So we know 2 coordinates on our graph. Okay, so let's get to the calculus part. So we're going to look at a sign diagram for dy dx. So the first thing I'm going to do is find the derivative of my function, which is 3x squared minus 6x. Okay, and then I'm going to do the same thing and look for the critical values. So where this is equal to 0. I get 0 equals 3x squared minus 6, and I'll just factor that. And then I get x equals 0 and x equals 2. And then I'm going to look for where the derivative does not exist. So this would be the same place as where the function doesn't exist in our case, which was none. And there are still no endpoints. Okay. And now I'm ready to put this on my sign diagram. I'll just move it up. So again, these go in as straight lines. And then I test values. And again, this is a sign diagram for dy dx. So I'm testing values in here. So I might test 1, which would be 3 minus 6, which would be negative. And then I can look at the factors, which were both there one time, so the signs will switch. And this is now telling me about my original graph that it's, increasing, decreasing, and increasing, because a positive slope is increasing, a negative slope is decreasing. And then I can take a look to see what, like when the derivative is equal to 0, what that's telling me about the original graph. So if I'm increasing and then decreasing, right here I get a maximum value. And if I'm decreasing and then increasing, right here I get a minimum value. So we can actually find the coordinates of these. So this will be at 0, and I'm going to put it into the original y, and I get 4. So 0, 4. And then I already know the coordinates for 2 because I found it up here. So 2, 0. Okay, so this is a max, could be local, is going to be local, and a local min. Okay, because it's where the derivative equals 0, which tells us in the original graph there's a max or min. Okay, let's take a look at the sign diagram for the second derivative. So the first thing I want to do is find it. So 3x squared minus 6x, so t squared. So it's going to be 6x minus 6. So hopefully you can see I'm taking the derivative of the derivative. And then again, I look at my critical values, so where that is equal to 0. So I get, and this is at x equals 1. And again, there's nowhere where this doesn't exist. I mean, it's just linear. So none. And there's no endpoints. Okay, and then I'll pull my sign diagram up and we'll label it. So we put in a 1, and that's it. And now this is the sign diagram for the second derivative. So the plus and minus are going to be concavity, because that's what the second derivative tells us about the graph. So if I put in a number like 10, bigger than 1, I get a positive. And then the factor is only there once, so the sign switches. And so this is concave up and concave down, which makes this a point of inflection. Okay, and then I can find the coordinates for this by going all the way up here and putting 1 into here, and I get 1 minus 3, which is minus 2, plus 4, which is 2. And this is a point of inflection where the concavity switches. Okay, and now I am ready to put this all together on a graph. Okay, so I had intercepts at -1 and 2. And I had a point of inflection at 1 and 2. And then I had a max at 0, 4 and a min at 2, 0. Okay, and then I can look and see I need to be below the graph on to the left of -1, and it needs to be increasing, and it needs to be concave down. So I'm going to just try sketching this here. Maximum, change of point of inflection changes here. Okay, so I can label this to show you. So we're increasing, decreasing, increasing, we're concave down, up, point of inflection, max, min, x-intercept, x-intercept, and actually this is also a y-intercept. Okay. So it would have been easier if I had maybe brought my sign diagrams down so you could see them next to the graph, but hopefully you followed that.